In this video, we're going to be talking about rational numbers. Now, what are rational numbers? Rational numbers are numbers that can be expressed in the form a, sorry, a over b with the condition that b is not equal to 0, and a and b, a and b are members of integers or are integers. Yes. So let's give some examples. So examples are fractions, examples of rational numbers. So just right there, rational. Okay. So examples of these are fractions. Fractions are, so for example, 1 over 2, 3 over 4. All these are rational numbers. Over 4, 10 over 13. All these are rational numbers. Rational numbers with terminating decimals. So 1.5, 0.5, 0.125, all these with terminating decimals are rational numbers. 0.1011, as long as we've got terminating decimals, these are rational numbers. And also rational numbers with repeating or non-terminating decimals. So for example, if you put 0.5555, they're repeating and they're non-terminating. These are rational numbers. Or if you have 1 2 1 2 1 2, if you notice that 12 is consistent here, then these are rational numbers. So one way we can, so well, fractions are pretty easy, of course, and also the terminating decimals are also straightforward. But one thing rational numbers are going to focus on, well, what I think you really need to learn is how to handle non-terminating decimals, because if you're told to convert this into a fraction, now how would you do it? Because you can't obviously use the old-fashioned way of yes, but to, so if you are told to, and then let's do that to show that's non-terminating. So if you are told to do this and to find, usually traditionally what we do is simply this over 10, right? This would be, this is simply, sorry, this would simply be equal to 15 over 10. Quite simple. So, but if you can, given a situation like this where the decimals are of course non-terminating, so you really can't use this method. So what we'll do instead is let's do that. We need to simplify this. Simplify it as in we find another way to write it. So you identify which numbers are repeating and then do this. So yes, 1.12 bar. I like to use the word bar, but don't exactly memorize it. But yeah, I just like to use bar. So if you've been given 1.3 into 1.222, something like this, or 3. So in this situation, you can this is a terminating one, so this you can just simply use a partial one, and but then if you have, sorry, if you have maybe 7 7 7 7, so we can see that 7 and this dot, we can see that 7 is repeating, so we would say 1.7 bar. Write that 7 properly. 1.7 and bar, or if you've got 1.8 is repeating, same thing, 1.8 bar. Or if you got 1.127 127 127, so you can see that the 127 is repeating, so 127 bar. Now if we are told to turn this into a fraction, let me just turn this into a fraction. So 2.5. So 5, how would you tell this? So it's say 2.5 over 10 because, well, we count the number of decimal places, so this is 10. So if we simplify this should be equal to 5 over 2. Okay, so this is 25 over 10, which will give us 5 over 2. And we also have another example, 1.1025. Convert this into a fraction. So this is simply be 1.1025 divided by, so 1 2 3 4. So 4 zeros, that means 10,000. So divided by 10,000. So this should be equal to, I can use as 25, so I can use 25 into this, which should be 441 divided by 400, or 400. So this is I think this is as far as we can go for this one. And let's try out another example. Try 0.3 bar, 0.3 bar. So for this one, we know that 0.3 bar simply means 0.3 and 0.333, and it keeps going. So we cannot use the same method. So what we should do instead is say let x be equal to 0.3 bar, 0.3 bar. So if we let x be 0.3 bar, okay, let's bring the bar in front and leave another 0.3 inside. So what we do is we move this one decimal place 1, so that means it's going to be 10x, which will make this equal to 3.3 bar. Remember, we've moved one decimal place. Okay, then we can subtract. Now we can subtract x from 10, which will give us 9. So we're subtracting, which will give us 9x. We're subtracting 3.3 bar from 3, 0.3, which will give us, of course, 3. Not forgetting negative, and all this over 9. Okay. 9 over 9 over 2 over 9. This to cancel out. 3 into 3, 1. 3 into 3 into 9. That's 3. And so our final answer, and the negatives cancel out, of course, and our final answer will be 1 over 3. And you can punch this into the calculator, and you're going to find that 1 divided by 3 is going to give you 0.3333, and you just keep going. Of course, we could have done all this. You can still do as well 0.3 is the calculator, and it will, well, it's not going to give you anything. But if you do your final answer, punch it into a calculator, it will take you back to this, and you know your answer is correct. Let's try out another example. 0.101222. Okay, let's do something like this. Okay, so first we recognize what is repeating exactly. So we say 0.10, and you can see that the 12 is repeating. So 10, 12, then you put the bar on top. Okay. Then we follow the steps we had here. So we say let x be equal to 0.102. Okay. Yeah, 102. From here, we have to move the decimal place. So we want what is repeating to be on its own, to be this side. I say want what is repeating to be both before the decimal place and both after the decimal place. So like what we did here, we moved it once because we wanted 1 to be before the decimal place and after the decimal place. So 3. Yes. So in this case, we have to move 1, 2, 3, 4 decimal places. To move 4 decimal places. That's so for x. That means our x will have to be 10,000. 10,000. This means 10,000 is equal to 10 point. So that you don't waste your time. First, you have to do the 10, ensuring that it's just 10 and the 12. Then, so you can just go straight into it. You can just say 10,000. You just say, okay, you want what is repeating to be on this side, 1 to be on this side, and another part of it to be on the other side of the decimal place. So this is what we have: 10,000, 10,012.12. So if I put the x here, 10,000 x, I can put something x 10,000. So then we subtract. So we subtract the values on top, and 10,000 minus x will be 9,900. So this should be 9,900x, 900x, which is equal to, so when we subtract this, we get 1,002. Okay, 1,002. So we make x satisfy the formula by dividing over, and this to cancel out, and x is equal to 1,100. And remember, in math you don't use calculators, so we cannot simplify this any further. Let me try something. So divided by 0, 0. Actually, you can. So you can simplify this to 167 over 165. Okay. But remember, this would take you a lot of time to find what can go into 1,200 and 9,900, and a lot of time and time that you don't have because in the exam. So I would prefer you to just leave it like this, but even if you do this, it's okay. It's okay. So that's it for the video, and we'll continue to in the next thing.